So what I want to do with this video is just go over some things from the exam that I saw, maybe some stuff that could be clarified. I don't want to work through the exercises. You've got the key, so you can look at how they were supposed to be worked. I just want to kind of address concepts, really. And then those last two discussion questions, look at the key for that. I'm not going to go through that. There's a lot of detail in there other than to say, you really need to read and participate in those discussions. Make sure you understand what's being said. If you don't, then in the discussion, you should ask, what does this mean? I don't understand what you're saying, or whatever it is. So let's look at those exercises. The very first exercise had to do with a circle. And I think what threw a lot of people is the equation of a circle was not given. And I just want to talk about how the circle is really part of a more central idea. I want to pull together several ideas here that are useful for us that are all really based around one idea, and that's the Pythagorean theorem. So remember, from Pythagoras, we have on a right triangle this relationship between the sides of a right triangle, a squared plus b squared equals, and I'm going to say r because of how it relates to a circle. So this is really the basis of measurement in 2 dimensions. If you have 2 points, and it can be extended to 3D, you just apply this twice actually in 3D, but for us we only work in 2D in this course, so we need distance, right? x1, y1, and say you have another point x2, y2. Well, this distance here, which I will call r, you can really just think of as the hypotenuse of a right triangle, right? And the 2 sides here, I'll call this a and this b. So from Pythagoras, we know a squared plus b squared is r squared. But what is a? A is the distance laterally, so from your x1 to your x2. So the difference in absolute value. You don't know which one is bigger, so I'll just say absolute value of x2 minus x1 squared. What is b? It's the difference in the y values, right? It's our vertical change. So y2 minus y1 squared, all of that equals r squared. Now, that's OK, but absolute value is a little bit cumbersome. Actually, why did I? Yeah, squared's good. So another way, remember, to write absolute value is just the square root of the square. Because when you square something, you make it positive. And when you take the square root, you undo the squaring, but you stay positive, or non-negative. So I'm going to rewrite that as r squared equals, so instead of using the absolute value, I'm going to take x2 minus x1. That could be negative. Squaring it makes it positive, and then the square root. And then all of that squared plus square root of y2 minus y1 squared, all of that squared. Now that looks cumbersome, but the square root and the square cancel, and this is squared here, so we simply have this, which hopefully we recognize as the beginnings of our distance formula. Take the square root. So the distance between 2 points is simply the sum of the squares of those differences, square root. But all that is the hypotenuse of a right triangle. OK, so Pythagoras leads to distance, but distance leads to the definition of a circle. Circle is all points xy that are a fixed distance r Well, I've drawn this from the origin, so which is how it was on the test, but we could generalize this. I'll do it in the simple case of centered at the origin here first. Well, what do we know? All the points on here should satisfy this equation because they're all a distance r from the center. So see if I have room right here. Now I'll move up here. So what do all these points have in common? Every point xy on there, the distance is r from the point 0, 0. So square root x minus the x coordinate squared, y minus the y coordinate squared. Square both sides of this, x squared plus y squared equals r squared. So Pythagoras is sort of the basis of everything. It leads us to distance, and distance leads us to circles. Now, if this center is not 0, 0, if it's some hk, then the more general form would be x minus whatever the x coordinate of the center is, y minus whatever the y coordinate of the center is. And then we have the equation that we learn in algebra for a circle centered at hk. So we should know this. We should know this. We should know how to find distance. We should know the relationship on a right triangle. All those things are really all just different iterations of the same idea in different contexts. Now, the very last thing that I can do here with this picture right here, just to throw one more important concept that's still based on this one idea, is on the unit circle. So let me just change this to a 1 now. On the unit circle, we define that x coordinate to be cosine and that y coordinate to be sine. Well, the equation of a circle of radius 1 is x squared plus y squared equals 1. But x is cosine, y is sine. That leads to our Pythagorean identity. Cosine squared plus sine squared equals 1. Or sine squared plus cosine squared equals 1. So all of this is really one idea, how the hypotenuse relates to the legs on the right triangle. The Pythagorean theorem leads to distance, which leads to circles, which leads to the definition of our trig functions, which leads to this is why it's called the Pythagorean identity, because it really comes straight from there. So we should be comfortable with circles. Even if you're not given the equation, you should always be able to generate the equation of a circle.